Now we want to discuss graphical method of approaching simultaneous linear equations. The truth is that anytime you want to solve any problem graphically, whether it is simultaneous or quadratic or the graphical methods of any other topic, there are two things you bear in mind. Number one, you must first of all construct table of values. Number one thing you do is construct table of values. You must construct table of values because it is from the table of values that you'll be picking the points you are going to plot on the graph. Without the table of values, you will not have a base where you will be taking figures you are going to plot on your graphs. Number two thing you do is you must choose a scale. You cannot go and write anything or construct anything or draw anything on your graph without a scale. Having a graph without a scale, what will I equate it to? It's like driving a car that has no gear. There will be no understanding of what you have drawn or what you have plotted. So the second thing that is important is choosing a scale. Choosing a scale. Now, this question we have chosen now is, if you can rewind your DVD, is the first question we solved on simultaneous linear equation. We used the elimination method to solve it. We got that x is equal to 1 and y is equal to 2. Now we are going to solve that same question. We also solved it with substitution method and we got the same answer, that x is 1 while y is 2. We got that x is equal to 1 and y is equal to 2 when we use elimination and substitution methods. Now we are going to use our graph book. I'm going to paste a graph paper on this whiteboard where I'm going to plot after the construction of our table of values and choosing the scale. Now you are going to discover that there are going to be two straight lines that you are going to see in the graph. Those two straight lines are going to meet at a point. And the point where they meet, from there we are going to read the value of our y. You will discover that it's going to be 2. And we read the value of x down. And you will see it's going to be 1. So when you are plotting the graph of a simultaneous equation, bear in mind that you are going to have two straight lines on the graph. And the solution to this equation is the point of intersection of the two lines you are going to plot. Read from the point of this intersection, read horizontally the value of y and read vertically down the value of x. Whatever you get will give you the solution to that equation. But for this one particularly that we have solved using the elimination and substitution method, you are going to discover that our x, the value we are going to read vertically down, is going to give us 1, while the value we are going to read horizontally, which is the value of y, is going to give us 2. Exactly what we got when we used elimination and substitution methods. Now we have come into the reading properly. First of all, construct the table of values. But that should be the beginning of your table of values and that should be an end. Let's take for values of x, for values of x from -2 to 2. So this is going to guide us in constructing our table of value now. So pick the first, you're going to construct the table of values of the two different equations differently. Take the first equation. The first equation says x plus y is equal to 3. So the first thing you do is when x is -2, when x is equal to -2. So begin to substitute -2 to be the value of x in the equation. You have -2 plus y is equal to 3. -2 leaving the left hand side of the equation, coming here we change to plus. So you are going to have y is equal to 3 plus 2. Y is equal to 3 plus 2 is 5. You have gotten the first value. The next one is when x is, the next number after -2 is -1. So when x is -1, begin to substitute -1 to the value of x in the equation. You're going to have that -1 plus y is equal to 3. That means y is equal to 3 plus 1. Y is equal to 4. The next value is when x is 0. After -1, the next number is 0. So we have when x is equal to 0. From our equation, we have that 0 plus y is equal to 3. I substituted 0 for the value of x in the equation. Now, y will be equal to 3 minus 0. Y is going to be 3. The next one is when x is equal to, after 0, the next number is 1. So when x is 1, substitute 1 for the value of x in the equation. We're going to have 1 plus y is equal to 3. That means y is equal to 3 minus 1. Plus 1 in the left hand side coming to the left hand side. Plus 1 in the left hand side coming to the right hand side, we change to minus. So we're going to have y is equal to 3 minus 1 is 2. The next one is when x is equal to, after 1, the next number is 2. When x is 2, we are going to have 2 plus y, and substituting the value of 2 for x in the equation is equal to 3. That means y is equal to 3 minus 2. That means y is equal to 1. Now that we have finished calculating the corresponding values of y when x is from -2 to 2. There should be an arrow here. It's not -2 minus 2. Now the next thing we are going to do is to put it inside table. Write x and write y. Draw a table. Write x and write y and draw a table. -2, -1, 0, 1, and 2. So the corresponding values of y that we calculated was when x was -2, y is 5. So write 5. When x was -1, y was calculated to be 4. When x was 0, y was 3. When x was 1, y was 2. And the last one when x was 2, y was 1. So this is the table of values. The table of value we just concluded constructing now is table of value for equation 1. We are going to do the same thing, constructing the table of value for equation 2 now. Because it's going to be the two table of values we are going to use to draw the straight line graph that I told you that are going to meet at a place where at the point of intersection we are going to read the horizontal value for y and the vertical value for x. So this is equation 2. We are going to construct the table of value for equation 2 now. Bring down equation 2. Equation 2 is 3x minus y is equal to 1. Remember, we are taking the values of x from minus 1 to, from minus 2 to 2. For values of x, from minus 2 to 2. So let's start. When x is equal to minus 2, wherever you see x, replace it with minus 2 or substitute it with minus 2. So from the equation we now have 3 into minus 2, instead of 3 times x, now minus y is equal to 1. Remove bracket. You have 3 times minus 2 will give you minus 6. Minus y is equal to 1. Take minus 6 from the left hand side of the equation to the right hand side, you change to plus. So we are going to have minus y is equal to 1 plus 6. That means minus y is equal to 7. And if minus y is 7, that means y is going to be minus 7. That means y is equal to minus 7. The next one is when x is equal to, the next number after minus 2 is minus 1. So when x is minus 1, we are going to see or get from the equation, you now have 3 into minus 1 minus y is equal to 1. If you open bracket, 3 times minus 1 will give you minus 3. Then minus y is equal to 1. Take minus 3 from the left hand side to the right hand side. Remember, if you change to minus plus 3. So in the left hand side you have minus y is equal to 1 plus 3. Minus y is equal to 4. That means y is equal to minus 4. The next is when x is equal to 0. The next number after minus 1 is 0. So we are going to have from our equation 3 times 0 minus y is equal to 1. 3 times 0 is 0 minus y is equal to 1. What you have here is minus y is equal to 1. And if minus y is 1, that means y is minus 1. After 0, the next number is 1. So when x is equal to 1, from our equation 3x minus y, we are going to have 3 times 1 minus y is equal to 1. 3 times 1 is 3. Minus y is equal to 1. Take plus 3 to the other side of the equation to change to minus. So we have minus y is equal to 1 minus 3. Plus 3, leaving the left hand side of the equation. Going to the right hand side, we change to minus 3. So we have minus y is equal to 1 minus 3 will give you minus 2. If minus y is equal to minus 2, you can cancel the negatives as the coefficient of both numbers in both sides of the equation. That means only y is now 2. The next, which is the last, is when x is 2, because after 1 you get 2. So when x is equal to 2, from the equation, 3x now becomes 3 times 2, then minus y is equal to 1. 3 times 2 is 6, minus y is equal to 1. Take plus 6 from the left hand side of the equation to the right hand side, you are going to have minus 6. So we are going to have, okay, minus y is equal to 1 minus 6. And 1 minus 6 will give you minus 5. You can cancel this, cancel this. That means y is equal to 5. So you can now construct the table of values, x and y. When x was minus 2, minus 1, 0, 1, and 2. So we calculated that when x was minus 2, y was minus 7. So we have minus 7. When x was minus 1, y was minus 4. So we have minus 4. When x was 0, y was minus 1. When x was 1, y was 2. And the last one, when x was 2, y was 5. So this is the table of values for the second equation. Now, we are going to clean up these processes of getting the values that we use in the table of values. When we do, we are going to have the two table of values for equation 1 and equation 2 only left here. And we are going to paste our graph book on the whiteboard and bring the camera closer, so that we are now going to use those table of values to plot the graphs that we are going to paste the paper on the whiteboard. As you can see on the whiteboard now, at the left hand side you will see the equation that we are solving that said solve graphically. X plus y is equal to 3. 3x minus y is equal to 1. You can see the table of value, the two table of values that we constructed. First one, the one on top, says table of values for x plus y is equal to 3. That is the first equation. The second one says table of values for 3x minus y is equal to 1. That is the table of value for the second equation. Then if you look at the right side, you will see the graph book pasted. Although I could see it is very far and you're not seeing it clearer, let me bring it close. This is a graph book. Okay, this is the closest it can come. Don't worry, later on we'll go close to it with the camera direct. Now if you look at the left side where you have the graph itself, you're going to see that I attached a ruler. I am going to use that ruler to explain to you what scale is and how scales are being shown. Now on the other side, that the exercise book side of the graph paper, is where I have the same table of values I have shown you that was at the left hand side. This table of value now, I copied it and I placed it at the exercise book side of my graph paper. That is exactly how you do it in case you are told to do this kind of a thing in your external or internal examinations. Now when you have done it, let me bring it closer so that you will see. When you have done it, what you are seeing here now is the table of value. Look at it. When we go closer, you are going to see it clearer. Okay, at least it is, you can view it now. This is the table of value. Then I want to emphasize more on the scale. I will bring the scale closer so that you can also see it. Okay, look at, you can read it now. The scale I wrote on both axes, 4 cm represents 1 unit. First of all, I want you to know that axis is the plural of axis, and we have the y and x axis in all graph plotting. The y-axis is the vertical axis, while the x-axis is the horizontal axis. I am going to use that ruler, as I told you, to explain to you how this scale was chosen. The scale of 4 cm represents 1 unit. How it was chosen and how you are going to be choosing your scales on your own. I'm talking of this ruler you see on the left hand side of the graph book. When I go closer now, I will explain to you why I pasted that ruler there and what I will use. I will use it to explain to you something about scale choosing. Before I go close with the camera, I will advise you to do one thing. Use your biro and paper and copy this table of values. This one. Okay. Look at the table of values there. Copy it inside your exercise book, so that when I will go close with the camera to the graph paper for the plotting, you may not be seeing the table of values on the whiteboard again. So you will now use the one you have in your paper, so that you'll be following whatever explanations I will be making. So you can see the table of value now. Just in the next few minutes, just copy it inside a sheet of paper or inside that paper. You know, originally from the beginning of the concepts, I told you should have a biro and a paper by your side, so that you'll be putting down whatever I am teaching you on the screen. So put down these table of values, because when I will go close to the graph paper, the one you are seeing here now, you will not be seeing the table of values again, and we'll be using the figures we have on the table of values in the plotting there. You have put it down. Now we are close to the graph book. I told you I want to explain why I pasted that ruler, this ruler now that you are seeing. Why I pasted it, I want to explain now. In the scale, look at the scale. We wrote that on both axes, 4 cm represents 1 unit. On both the vertical axis, which is the y-axis, and the horizontal axis, which is the x-axis, 4 cm represents 1 unit. Now come to the ruler. If you watch closely, this is the beginning of the calibration of the ruler. This place now, from here to here is 1 centimeter. You can see centimeters here. So from this place to this place is 1 centimeter. Then from here to here is 2 centimeters. You can see that these thick lines you see on the graph paper, these thick lines you are seeing, they are 2 cm apart. From here to here is 2 cm. From here to here is another 2 cm. And these gaps forms squares. From here to here, to here, and to here, back to this place is a square. It's a square. So this is a square, this is a square, this is a square, and it's a square of 2 centimeters. Now, why we chose that 4 cm will represent 1 unit is that distances from here to here, we are going to have 1. From here to here, we're going to have 2. From here to here, we're going to have 3. So in between every 4 centimeter, we're going to have 1. That is the 1 unit. And that's exactly the explanation of the scale we have, that 4 centimeters represents 1 unit. That means from this place to this place 2 cm, to this place 4 cm, we are going to have 1 unit. It will continue to this place, we're going to have the second 1 unit, which will make it 2. To this place, we're going to have the third unit, which will make it 3. And it's going to be like that. Now I'm going to remove the ruler. If I remove the ruler, then I will now start calibrating our axis, putting in figures based on what we have on the table of values. We're going to put in figures on this graph book that will now enable us to plot the numbers we have on X that corresponds to numbers on Y on both table of values. Into the business of plotting our graphs. The way you calibrate your graph paper depends on the values you have on your table of values. Look at the first table of value, the one for X plus Y is equal to 3. The values of X you have is -2, -1, 0, 1, 2. And you know that in your graph paper, this horizontal axis is the X axis. Now you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 squares on the horizontal. Now you are going to divide this in such a way that it will accommodate both the negative, like -2 and -1, and the positive, like +1 and +2 values of X. Remember that in the horizontal axis, as you have now, the left hand side should be the negatives, while on the right hand side you have the positive. So since you have equal negative values to positive values, the vertical line you are going to draw has to be at the middle of the paper in such a way that it will divide the horizontal axis into 2 equal parts, so that you have enough space to fit in both the negative and the positive values. So since we have 10 squares, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we are going to draw a line on the 5th square. That means 1, 2, 3, 4, 5, 6. So we're going to draw it on this place. What you do now is place your ruler on this and draw it. I am going to pause now. The next time you will see this graph, a line have been drawn on this place. You can see that I have explained to you why you draw the line here. You can see that I have drawn the line, and it has shown that it is thicker than these other ones. And if you look close now, you see that the place I drew it have just divided the horizontal side, the horizontal part of the graph into 2, because the figures we have on our table of value is balanced both on the left hand side, which is the negative, and on the right hand side, which is the positive. Now the drawing of the y-axis, which we are going to draw across, it will also depend on the values of y. Now the values of y we have here are, look at the table of value, we have 5. So they are all positives, while in the second one we have negative and also positives. But look at the positive. The highest positive we have here is 5, and the higher positive we also have here is 5. but the highest negative we have here is 7. This means that down this side of, on the negative side of the graph paper, we are going to give more space so as to accommodate -7 and leave a shorter space up, because we have 5 only. You know that -7 is more elongated than. I advise you to pay attention to what I want to explain now, because we are going to change our scale. I know why I chose to do it that way, so that you understand the things, the principles that will guide the scale you choose. From the table of values, we have -7 as value of y and +5. If you add minus, if you forget about minus, if you add 7 and 5, you are going to get 12. Now you have chosen that 4 cm represents 1 unit. Now count the 4 cms. You know that from here to here is 4 cm. That's 1. Second 4 cm. Third 4 cm. Fourth 4 cm. Fifth 4 cm. And sixth 4 cm. So we have 1, 2, 3, 4, 5, 6, 4 cms. Whereas what we have here is 7 plus 5, which is 12. So if you go by this scale, 4 cm represents 1 unit along y-axis, it will not work, because you won't be able to put in all these both the negative and positive values. So we are going to change the scale. You can see the second scale I have chosen now. Hope you can see it. Along y-axis, 2 cm now will represent 1 unit. It is now only the along x-axis that our former scale 4 cm will represent 1 unit. I know why I did it like that, so that you will be able to know and understand that scale choosing has principles that guides them. So we are no more using this first scale. It is this second scale that we are using, that says along y-axis 2 cm represents 1 unit. I want to explain to you why 2 cm represents 1 unit will work along y-axis. Now as you have added, and that's where you will do, 7 and 5 will give you 12. When I use ruler to explain to you, you discover that from here to here was seen to be 2 cm, 2 cm, 2 cm, and it goes down to the list. Now we added 7 and 5 and we got 12. Now let's see if spaces of 2 cm is up to 12 on this graph. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That means it's going to work. Then what you're going to do is, because of -7, you are going to count 7 2 cms to be below. So you start from here. 1, 2, 3, 4, 5, 6, 7. So this place is the place you are going to draw your horizontal line. You will draw a horizontal line here. Then you discover that you are going to have in the upper side 1, 2, 3, 4, 5 to accommodate the +5 that you have as values of y. So on this, I am going to draw the horizontal line now. The horizontal line that will pass through here. When next you see this graph book, you are going to see the horizontal line. See the horizontal line that I have drawn. Now let's go to the scale. You will find out that all our values can enter now. along x-axis. The x-axis is this horizontal axis. You can put x here. The y-axis is the vertical axis. You can put y here. You can put y here. That's y-axis now. Okay. Now we can fit in our values at the point of intersection of the two axes. Put 0. This is 0. This 0 begins every axis. Okay. Now let's put the values of x first. Remember, along x-axis from our scale, along x-axis 4 cm represents 1 unit. That means on the positive side of the graph, this is 2 cm, this is 4 cm, so you have 1 here. This is another 2 cm, this is another 4 cm, so you have 2 here. And remember, you have only 2 units along the positive side of the x in both table of values. Now in the negative, we're going to have -1 here, because from here to here is 2 cm, from here to here is 4 cm, and you know that you have 4 cm represents 1 unit. So you have 1 unit in every 4 cm. From here to here is 4 cm, then from here to here is another 4 cm. So here you have -2. Okay, you can see the calibration of the x-axis. On the left hand side we have -1, -2. On the right hand side you have +1 and +2, while at the center you have 0. Then the next thing we do now is to calibrate the y-axis. On the y-axis, our scale is along y-axis. 2 cm represents 1 unit. From here to here is 2 cm, so you have 1, +1 up. The next one will be 2. Next one will be 3. Next one will be 4. Then the last one will be 5. So you have the positive side of the y-axis calibrated 1, 2, 3, 4, 5. Each 2 cm represents 1 unit. Now below the negative you have -1 here. Now have -2, -3, -4, -5, -6, and -7, which is the last. You can see the calibration now from -1 to -7, which agrees with our table of value that has the values of y from -7 to 5. Now the next thing now is the plotting. Let's first of all plot the first equation of x plus y. X plus y is equal to 3. So we're going to use this table of values, and that was why I told you you should write down, copy down this table of values in an exercise book, so that when I'll be plotting now, you will be looking into that exercise book. Now we are going to plot the first value here, -2 for value of x and 5 for value of y. -2 value of x, remember this is the x-axis. This is the x-axis. So we have -2 as value of x. So this is minus 2 as value of x. Then the corresponding value of y is 5. So we have 5 as corresponding value of x. So between this 5 and this 2, the line of 5 is this way and the line of 2 is here. So the place they meet, which is here, you are going to put your point. So put your point here carefully and neatly. You can see the point I put. That is first plotting. Go to the next. The next you have minus 1 and 4. Minus 1 for the value of x and 4 for the value of y. So come to the graph. This is minus 1 and this is 4. This is 4. So the place, the line of 4 goes like this and the line of 1 goes like this, and two of them meet here. So the next point you are going to put is going to be here. You're going to have it here. So put your point there. You can see the second point. Okay, the next value is 0. X is 0 and y is 3. X is 0 this place and y is 3, and this is where y is 3. So the next point is this place. So put your point here. You can see the third point we have put now. The next value, the next value is 1 and 2. 1 for the value of x and 2 for the value of y. So this is 1, the value of x, and 2, the value of y. So the two lines meet here. So you're going to put the next point at this place. So put it. Now the last, the values are 2 for the value of x and 1 for the value of y. 2 for the value of x and 1 for the value of y. This is 1 for the value of y. So trace the line and see where it meets with 2. So the next point is here. So plot this place. So you can see now the point that we plotted. This is the first one, this is the second one, this is the third one, this is the fourth one, and this is the fifth one. So we are going to use a ruler and join these points. It's going to give us a perfect straight line. I am going to drop the camera now, and by the time I open it again, you are going to see the line joining these 5 points, and that is the first line we got from our equation. X plus y is equal to 3. Now you can see that I have joined the points with a perfect straight line. So on top of the line, you write the equation. Very, very necessary. This equation, x plus y is equal to 3. Write it on top of this equation. Sorry, on top of this line. X plus y is equal to 3. It is very, very important. If you do this in your external examination or even internal, your teacher will know that you really know what you are doing. Write the equation. X plus y is equal to 3. You have finished with plotting of the first equation. Now let's plot the second equation. Second equation is, this is the table of value for the second equation. The first value of x is minus 2 and the corresponding value of y is minus 7. So look for minus 2 as the value of x. So this is minus 2. Y has minus 7 here. So this line meets with the line of minus x here. So join this line with this line. You can see that they met this place. So put your point here. this place. Put a point. You can see it. -7. -7, value of y, and -2. -2, value of x. The point of intersection of the two lines is here, and that was where we put our point. The next one is go to the table of value, -1 and -4. -1, the value of x. So look for -1 value of x. You can see that this is -1 for value of x, and the corresponding value of y is -4. So this is -4 for value of y. So the place the two lines join now, this place is the next place you put your point. It's going to be -1, -4. This is the place they join. So put your point at this place. That's the second plotting now. The thirds go to the table of values, 0 for value of x and -1 for value of y. This is 0, value of x, and this is -1, value of y. So the next point is going to be here. Okay. The next is 1, value of x, and 2, the value of y. So go to where you have 1 as value of x. Look at 1, the value of x, and the corresponding value of y is 2, as you can see in the table of value 1, 2. So you have the value of x is 1, and the value of y is 2, and 2 of them meet here. This is 2 and 1. 2 of them meet here. Already you have a point there existing. So you're going to use this point when you will be joining your line. Now the last is 2 for value of x. Look at 2, and 5 for value of y. Look for 2 as value of x. This is 2, and 5. Look at 5 for value of y. So join the lines, this line and this one. So they met here. So put your point, which is the last point here. Going to be here. So you can see the lines we join. I'm taking the camera away from me so that you see. This is the first one. This is the second one. This is the third one at 0. This is the fourth one, and this is the last one. So we are going to use our ruler. The next time you see the graph now, our ruler have joined these lines. Line. I have drawn the second line. Look at it. Start from here, and it went up. It crossed the first line we drew, this place, and it went up. Remember I told you that when you draw the two lines, they will meet at a place, and from that place you trace the horizontal value for the value of y, and the horizontal value this way for value of y, and the vertical value this way for the value of x. Now you can see that the vertical value of x meets here at 1. That shows us that x is equal to 1. And if you trace the horizontal value, you'll find out that it meets 2. That shows that y is equal to 2. That is exactly the values we got for x and y when we use the substitution method and the elimination method to solve this equation. X plus y is equal to 3, and 3x minus y is equal to 1. This shows you that no matter the method you use, either the substitution, elimination, or graphical method in solving your simultaneous equation, you will get the same answer.